Hi, welcome back. This video is something to do with the application of potential energy equation that we have learned in the previous video. So it shows how do we apply it to solve problems related to potential energy and all those given condition. So first example problem we have, what is the potential energy? So question is, what is the potential energy? So it means that we're solving for the potential energy PE. So we want to figure out the value of potential energy. The mass of the object, I immediately said it's a mass of the object because that is 1 kilogram. So we go back to the table that we just created in the previous video. Kilogram represents mass. So this is our mass. While it's sitting on a shelf of 2.5 meters high. So meters, if you notice, I've been circling the units. Meters stands for height. So this is our height. Since we're solving for potential energy, we can use the table in the bottom. Okay. Potential energy, we use the equation PE equals mgh. So let me just write it down. Potential energy is mass G times height. Again, so if we review the table that we have earlier, in order for us to solve for PE, we must know the mass. In our case, we know the mass. We should also know the height, which is 2.5 meters. And at the same time, we should know the acceleration due to gravity. But since we are on the surface of the Earth, based on this problem, we know the value of acceleration due to gravity on the surface of the Earth, which is equivalent to 10 meters per second squared. So let's write it down that the value of G on the surface of the Earth is always stated at 10 meter per second squared. So we all know the values, so this is basically a direct plug-in of values. So mass of 1 kilogram, so let's put the units. 1 kilogram multiplied by 10 meter per second squared. And then we have height of 2.5 meters. Kilogram, meter, so that will give us meter squared, so this is newtons. So when you multiply 1 and 10, kilogram meter per second squared is basically newtons. And then you multiply it again by meters, so Newton meter is basically equivalent to joules. So our steps is basically correct. So we can say that a potential energy, there's no more space right here, so let me just show you guys. So potential energy is 10 times 2.5, so that will give us 25 Newton meter, or also known as 25 joules. So that's your answer for example question number 1. Okay. So now the second question. Okay, second question. Let us read. Second example. Determine the amount of potential energy. So determine the amount of potential energy. So we're trying to figure out the value of the potential energy. So again, we are going to be solving for the potential energy, PE. And from the notes that we have, potential energy is mass G times height. Okay, so we are going to use that equation. Now let's continue reading. Let's continue reading. So according to the problem of a 5 Newton book. So 5 Newton is not your mass, but instead Newton represents the weight, or Fg. Fg, or also known as weight, is moved to 3 different shelves on a bookcase. The height of the shelf is 1 meter. So we have 3 different heights. So we have 3 different heights. So the first height is 1 meter. The second one is 1.5 meters. And then the last height is at 2 meters. So we're basically moving an object, and that object is a book. On a bookshelf or a bookcase would have different shelves. So 1 meter, 1.5 meter, and 2 meters high. Now the thing is mass times G, but we don't have the mass. However, in our notes, we also know that Fg is equivalent to mass times g. So basically, we can modify the way we write our potential energy equation into Fg, because Fg is equivalent to m times g. F sub g, which is force of gravity or weight, you multiply it by the height. So we're just going to use this same equation on all three different heights. So first height, let's call this one height is equivalent to 1 meter. So the potential energy of a 5 Newton book being lifted at a height of 1 meter. And if you notice, that's Newton meter. Just like the first example, Newton meter will give us joules. So therefore, our solution is basically correct. 5 times 1 is equivalent to 5, and that's the unit of 5 joules. 5 joules. So for letter B, now this time, height is at 1.5 meters. So using the same equation of potential energy equals the weight times the height. So therefore, our potential energy is 5 newtons multiplied by 1.5 or 1.5. So this will give us a value of 7.5 joules. Now in our last calculation, letter C, when height is equivalent to 2 meters, using the same equation as PE equals Fg times height. So that will be equivalent to 5 newtons multiplied by 2 meters. So therefore, the potential energy is 10 joules, which is Newton meter. So this will be your answer. 3 answers for question or example letter or number 2. So the higher the object is being raised, the greater the gravitational potential energy. Last but not least, you are standing in your inline skates on top of a large hill. The potential energy is equal to 1000 joule. The last time you checked, your mass was 60 kilograms. What is your weight in newtons? And letter B, what is the height of the hill? Okay, so let's solve for letter A first before we solve for letter B. So what is your weight in newtons? So question is, what is your weight? So basically for letter A, we are solving for the value of Fg. So what is your Fg? Okay. So far, what is provided to us in our problem? We know that there is 1000 joules of potential energy. So this is your PE, 1000 joules. And then it says the last time you measure yourself or you check yourself, it is 60 kilograms. Again, if we go back to our notes, kilogram represents mass. So therefore, this is our mass. Okay. So how about Fg? How do we solve for Fg? As part of your lesson also, or your notes in the previous video, Fg is equivalent to mass times g. So Fg is mass times g. So let's plug in the values of Fg, and that is your mass of 60 kilograms. And I think the last time we checked ourselves, we are still in the planet Earth. So the acceleration due to gravity on planet Earth is still 10 meters per second squared. So all we have to do is multiply 60 by 10, corresponding unit of kilogram meters per second squared. When you multiply this 2 unit, will give us Newton. So therefore, our equation is correct. 60 times 10 will give us 600 newtons. So that's our answer for letter A. So now our answer for letter B, we are solving for height of the hill. So what is your height? Okay. So letter B, let's solve for the height of the hill. Going back to our notes from the previous video, to solve for height is basically potential energy divided by mg. So let's copy that equation right here. H is your potential energy divided by mass times G. Potential energy is given at 1000. Mass is given at 60 kilograms. And we all know that this incident happened on the surface of the Earth, so therefore the acceleration due to gravity will still be 10. Therefore, let's plug in those numbers. Potential energy is 1000 joules divided by mass of 60 kilograms divided by 10 meter per second square. So our height is equivalent to 1000 divided by 600, or 6 times 10. So the height is measured at 1.67 meters. So therefore that will be the height of the hill. Again, if you have any question later, please feel free to contact or send a comment below.